Hello everyone, my name is Sreerag and today we will be discussing about the topic potential energy of an object on a height. We already know what's a potential energy, right? So it basically is the energy that is in an object when it is at rest. And we will be learning today what happens to it when it is taken to a height. Hope you all are ready. Let's start our session. An object increases its energy when raised through a height. It says that when an object which is at rest, when it is being raised through a height, its energy increases. How does that make sense? And why does the energy change? It's basically here, and when I'm trying to lift it, just look at the case of this mouse. It's now at rest in my hand, and when I'm lifting it from one position to a certain height, its energy increases. How and why? The answer is right there. Let's look at that. So it is because the work done on it against gravity while it is being raised. So it says that while I'm lifting this mouse from its original position to a certain height, gravity is acting on it. You all know about gravity, right? Gravity is a force which pulls everything towards itself. So while I'm lifting this mouse or any other object, gravity will be acting on it and it is trying to pull this downwards. While I am trying to lift it up, the gravity is applying a force which tries to pull this mouse down. Okay, so the energy present in such an object is gravitational potential energy. So such energy which which an object has while it is at a height is called the gravitational potential energy. And the gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against the gravity. What does it say? So let's just get deeper into that point. The gravitational potential energy. So we already talked about what is the gravitational potential energy, right? It's the energy possessed by an object at a certain height of an object at a point above the ground. So the gravitational potential energy of an object at its point just above the ground is defined as, we can classify that energy or that gravitational potential energy as the work done. It is defined as the work done in raising it from the ground to the point against gravity. That means if the mouse is at this point and while I'm lifting it, the height will be this much, right? So at this point, the amount of energy it possesses is equal to the amount of work done that I have to do to take this mouse from its initial position to that certain height. Okay, so that the work that I am doing to lift this one to the certain height is equal to what? The gravitational potential energy. I think it's clear. Okay. Then it is easy to arrive at an expression for the gravitational potential energy of an object at a height. I think up to this it's clear. Then we will be moving towards the expression for that. So let's consider an object of mass m. Here, let's consider this object as of mass m. Here, this object can be classified as mass of m, and we are raising it to a height. Here you can see we are just lifting that one through the height edge. Okay, this height, and the minimum force required to raise the object is equal to the weight of the object. As we know, while I'm just lifting this mouse from its initial position to a certain height, the minimum amount of the minimum amount of force that I have to put put on this one is equal to the mass of the mouse. Okay, so the minimum force should be equal to the weight. Okay, the weight of the object. I think it's clear. So as we all know, weight is equal to the expression for weight is mass into gravity, right? So mg, and the object gains energy equal to the work done on it. And the object if the mouse is the object, then the amount of energy gained by the mouse will be equal to the work I'm doing on it. Okay, the equal to the force that I'm applying on it. And the work done, let's consider the work done as W. Okay, in the case, let's consider the work done as W. And we also know the expression for work done, right? Work done is equal to work force into displacement. In this case, force is equal to, we already mentioned that the minimum force required to raise the object is equal to the weight of the object. So mg, and how much height we are displacing it. Let's consider it as h. We already mentioned here. And since the work done on the object is equal to mgh, okay, as we know, the work done is mg into h, that is mgh. So the work done on the object is equal to mgh, and energy equal to mgh unit is gained by the object. That means we already said that the object gains the energy equal to the work done on it. Okay, and here the work done is mgh. So that much of energy is gained by the object, and that is called potential energy of the object. Okay, that's the potential energy of the object at that height. If I am forcing this object, or forcing this, or taking this mouse from its initial position to final position, the amount of work that the amount of energy that I'm giving to force or work done that I'm giving to this mouse, it is equal to the amount of energy gained by the object, and that will be equal to mgh. So the potential energy of an object at a certain height will be mgh. I hope that you all got how we get the potential energy of an object at a certain height is equal to mgh, right? And also, here we can see that the work done by the gravity depends on the difference in the vertical heights of the initial and final position of the objects, and not on the path along which the object is moved. So in this figure, we can see it clearly. Like if I'm taking the mouse, okay, in the picture you can understand it by, but here I am showing you a demo. Look at my hands. Here I'm taking the mouse, and if this is the height that I have to take the mouse, okay, from this is the initial position, and I am taking the mouse just vertically. Okay, this is the one side, like this is path one. Okay, this is path one. I'm taking the mouse from its initial position to this position, let it be P or A. Okay, so this position. Okay, so I'm just vertically applying force and it reached there. And if I am going like this, I'm instead of going vertically upwards, I'm just going like zigzag model. So it doesn't matter how I am going. Okay, it doesn't matter which path I choose. If the path is vertical, or if the path is zigzag, or if the path I am using is anything else, it doesn't affect the energy it has. The only thing that affects the energy or the potential energy is the height difference, or the direct height difference between these. It doesn't care about how I go. In the second picture, you can see it goes like from from A, I'm taking this object like this. But in the first position, first picture, you can see that I'm just vertically pulling it up. Okay, pushing it up. So there is not that much of difference. There is no difference, not that much of difference. There is no difference while about how I'm taking the object. Okay, how we are how we are giving the energy, or how we are forcing the object from its initial position to final position. It doesn't care about the path. It only depends on the difference in height. Okay, so that's about the topic. What that's about the topic. The height, the potential energy of a object at a height. So let's do a problem regarding this one. So the question is, find the energy possessed by an object of mass 10 kilogram when it is at a height of 6 meters above the ground, given that g is equal to 9.8 meters square. So we know the equation for work done, right? So we have to find the energy possessed by an object, and we know the potential energy or the energy possessed by an object is equal to work done, right? Work done in moving it from its the initial position to final position. So it will be equal to W is equal to mgh, and m is equal to 10 kilogram, and height h is equal to 6 meters, and g is given as 9.8 meter per second square. So everything here is given already. We just have to put the values, and we will get the equation as, or we will get the answer as W is equal to 10 into 6 into 9.8, which is equal to 588 joules. So that's the answer. And I will give you a similar problem like this as homework, and I hope that you will do it as homework, and I will attach the answer in the notes. That's all about this topic. See you soon in the next class.